Hello everyone, welcome to the GameLift webinar. We're going to give just another couple minutes to make sure everyone gets here on time. While we wait that extra minute, feel free to download the links from the attachment section and also ask questions at any time during this webinar. We'll be answering all the questions as they come in. Alrighty, let's get started. So today we're going to be talking about deploying games on AWS with Amazon GameLift. So GameLift is a managed game server hosting service put out by Amazon. And so we here at Mission, we are an advanced consulting partner, work with many customers to launch games into AWS, and actually have used GameLift for projects and help customers launch their own games using this technology. My name is Lance. I'm with the platform team here at Mission, and I'm going to be kind of presenting the topics and kind of going over the GameLift service as a whole with all of you. So we're essentially going to provide an overview into the GameLift service as well as the components that comprise it as a whole. And we'll talk about each of the individual pieces and how they together kind of form the whole GameLift service and how they can all be leveraged to build and run games at scale. So as stated before, my name is Lance. I'm the platform manager here at Mission. The platform is essentially the underlying technology, services, and stack that kind of powers a lot of the operations here at the company. My team and I are often working on software development efforts, building new tools and services, and launching new APIs and capabilities for our teams, including our professional services teams and DevOps teams who often work on these types of projects involving GameLift and building games on the cloud. My background I come from systems administration, and I kind of slowly moved more into software development and spend a lot of my time tinkering and learning. I've always been a big Linux nerd and got into IT wanting specifically to do this fancy new DevOps term and write scripts and automate deployments and process and workflow and all that. And so during my tenure here at Mission, I've actually been on the professional services arm of the company and delivered some GameLift projects and many game projects overall. Mission as a whole is the company I work for. We're a service delivery technology enablement company, so we work with companies large and small to help them build in the cloud. Various dynamic workloads, anything ranging from simple content management systems to complex enterprise ERP solutions. Pretty much anything involving AWS automation, we are partners and can help address a lot of those technology issues and provide services and support for all of those. So to add to that, our technology teams are 100% AWS certified. All of our engineers go through the AWS training to get certifications. Currently at 27 pro certs and over 40 engineers, and we're growing constantly. So in addition, we're also a well-architected review launch partner and an immersion day partner. So those are other additional services that we offer to provide the kind of the best practices to our customers and help everybody build from the best practices pool from Amazon, because there's so much to keep on top of. And so we provide that service to help keep things aligned and in best practices and secure. So today we're going to be talking about GameLift specifically. If you're not familiar, GameLift is a managed service for running games in the cloud, and it's essentially a all-in-one, out-of-the-box solution or service in which there's no need for operators to focus or worry about the infrastructure itself, and it's really the whole point of the service to abstract away all of the management of servers and infrastructure, because there's a lot of components to it. And so GameLift is just a service on top of traditional compute environments that allows you to basically upload a copy of your game code, and it will run in GameLift servers, which you can scale up as individual pools of compute. You can launch GameLift servers in several regions and then combine them all together and really have a global infrastructure of game servers that are running a multiplayer game on AWS, all very simply. So the goal of the service is to eliminate the requirement to have the extra technical capabilities. There is a ton to manage already just on the AWS infrastructure alone. If you were to go about deploying a game by yourself or just on traditional EC2 or auto-scaling. So there's a lot of server configuration and management aspects that GameLift is trying to abstract away and just provide a very simple way to take a game and just run it at scale without all the extra stuff. And so that's GameLift kind of in a nutshell. There's a lot of features and components to it which make it a very good option for game developers and studios to run a game fairly cheaply, especially with the ability to run spot instances. If you're unfamiliar with Spot, it's basically a marketplace you can leverage to run servers and compute for cheaper than the typical rate. And so with all the features and the capabilities of GameLift, it makes it very not only easy to run the game, but cheap as well. And so we're going to talk about some of the components a little bit more in depth and how they can actually be leveraged to run a game. So this slide encompasses all the various components of GameLift. And to run through them briefly, there are builds, which are essentially just software bundles of your game code. It's just an application artifact is all it really is. There's scripts. This is a somewhat new feature, but lightweight JavaScript-based applications can now be run just right off the bat using something called real-time servers. Servers without the requirement for the really the dense game server images and applications, just really light. That's intended for lightweight JavaScript games, basically. Fleet is the pools of compute that are referenced in GameLift. So it's basically your servers. The game servers in GameLift are referred to as fleets. And it's essentially equivalent to an auto-scaling group if you're familiar with traditional EC2. It's just a pool of compute that can be scaled up and down and treated as its own little version of your game. Aliases are essentially an abstraction around the fleets themselves. So when you create a fleet, each fleet gets its own ID or this designator, and it's this big long string, and it's not really a human readable thing. So the alias is an abstraction around it, kind of like a DNS record, a CNAME or something, and you can reference a fleet using its alias. And so the point of having the alias, so it's very easy to swap traffic. So as you're launching new versions of the game, you launch a new fleet, and once it's tested and you're ready to route production traffic to the fleet, you update basically the alias that you're pointing to. And so rather than needing to constantly be rotating fleets and tracking all the IDs, you can refer to the friendly, more human-readable alias instead. Matchmaking is a component of GameLift in which you can basically define rules which pair players with each other. So depending on the multiplayer game that you're operating, if it's a competition, like a fighting game or something, you can create matchmaking rules based upon players' skill sets or game progress, and try to pair players together who are similar in skills and abilities, so that there's a better player experience. And so with matchmaking, you can provide your own attributes and set up rules based upon whatever suits your game. And so the matchmaking service inherently ties into the next component, which is queues. So queues is essentially, as it sounds, the queue is what queues up players getting ready to play, and the queue is actively responsible for finding available game sessions that are running on your fleets and then pairing users or players to those game sessions. So that's kind of the quick run-through of all the different components, and so we'll actually dive into each of them and talk to them a little bit more in depth. Alrighty. So before I go into this build section, there was a question asked, if I choose not to use GameLift, how much work is it for me to run a game on my own? What's involved? So great question. It really depends on the complexity and the requirement of the game, meaning all of the other technologies involved. It's definitely not a requirement to use GameLift by any means, but depending on what your game needs, it may be an easier option. So for example, typical multiplayer game, you're going to need servers or EC2 instances running. You typically want them running in an auto-scaling group. You would typically want a load balancer in front of them so you can route traffic. Most of the time there's a database involved, so the certain database engine will need to be running and available to those machines. Some games may need a cache of some sort, so you may need a cache instance. And depending on how the game works and operates, certain network topology. So there's a lot more planning and work involved with building it on your own or doing it all yourself. And that ties into this whole other facet. The best practice in the industry right now is using software tools such as infrastructure as code, in which you can write and define templates to build all the infrastructure. And so you're treating your infrastructure like versionable software pretty much, and checking in code into Git repositories. And so it's additional overhead because you have to know more things. So with GameLift, you basically, know your game, you write your game code, you develop it, you launch it into GameLift. Doing it on your own, you have to know your game code, know how to bundle it, ship it, but you also have to then know how to build the infrastructure, how to manage that infrastructure. If you have a database, a MySQL database running in the background, you're going to need to know how to admin and manage that MySQL database. If you're setting up cache or different technologies in the background, you're going to need to know how to set those up, and it's more overhead, more stuff that needs to be done, more things that need to be touched. Okay, so whoever submitted that question, let me know if I answered your question sufficiently, and if you have any follow-ups, also let me know. I can respond to that as well. So to go into some of the components, the first one that we're going to talk about is the builds. So GameLift, there's a concept of a build, so it's an object that's kind of stored in GameLift that you reference when you're creating fleets. But all it really is a version of your game code. So if I'm working on a multiplayer game and I'm developing it locally in my computer, I'm committing it into some source control repository. At any given moment, say my current commit of the application is version 1. If I upload that into the GameLift service, I upload my game code version 1 as a build. And on the GameLift side, you can tag and set metadata as there, metadata as well there. But the build is essentially just a copy of your game at that point in time. And so we recommend tying in a CI/CD pipeline or some type of automated process or workflow to take your application revisions and upload them into GameLift, into the build section, using whatever Git labeling scheme that you're using for your application as well to keep versioning aligned. But that's all a build is. It's just a copy of your game that's been uploaded to GameLift, and you're able to version it just like you would with your application code. But the build is necessary to actually run the game. So when you upload your game code and you have a build, those instructions contained within that build are what's used to actually serve the game and run on those fleets. I guess one thing I also want to include in there is that utilizing GameLift, there's still a requirement to build GameLift into your game. So how it actually works is in your game code, and within the application, you're actually going to need to import the GameLift SDK, just like a library within your code, and execute the functions that allow GameLift to kind of know the state of your game. So during certain functions, you can add in callbacks that notify GameLift when a certain event has happened. So it depends entirely on the game works. But GameLift in a nutshell is a way to extend your application code by importing a library that communicates with GameLift. So if I was writing a Python-based game, I would import the Photo3 Python SDK and make API calls to GameLift within the application code. So when that app code is running in a fleet, it's running on an actual game server, it's communicating to the GameLift service and notifying when players are joining and disconnecting, or providing status updates back to GameLift. So that is builds in a nutshell. So the next section is matchmaking and queues. Matchmaking is, in essence, is just a JSON representation of the rules that you want matchmaking to adhere to. And so the GameLift documentation kind of covers the rule sets and whatnot, but it's configurable to the point where you can base your matchmaking rules around attributes that are unique to your game. So if you wanted to match players based upon their skill levels and ability, you can define that in your matchmaking rule set. If you wanted to match players based upon their regional or locational, based upon their location, you can use that in the rule set as well. So it's really up to the operator to define what the matchmaking rule set is, but it's essentially just a component of the service which allows you to define that kind of outside of the application code. And it's kind of it's its own rules engine that you can kind of include into your process and manage all the matchmaking. So you don't have to write your own custom matchmaking software. So it's already just kind of natively part of GameLift and something that can be leveraged right away. And so matchmaking ties into the queues directly, because the queue is what's actually actively looking for available player sessions. So the queue's job is to look at all the fleets that you have running your game code, and it will find available game sessions and drop players into them. And then all throughout this, the GameLift API is being notified of statuses and players. Alrighty, fleets and aliases. So I mentioned before, but fleets are essentially just pools of compute. They're each equivalent to an auto-scaling group, and in fact, each fleet has its own auto-scaling settings which can be adjusted for the fleet. You can run them in multiple different types and modes. So you could have one fleet that's running C4 large and another fleet that's running C4 2x large. So you can run different sizes of servers depending on each fleet. And you can also run in different modes such as on-demand and spot. So previously, by default, every fleet would just run as on-demand, and you're paying the list price for those servers running in the background, right? But with spot, you're running spot instances on the background, and there's actually a capability which we'll talk about here in a few more minutes of GameLift, which will actually manage the spot instances on your behalf as well. And it is actually a best practice to run multiple fleets depending on your availability. And in fact, on some of the global deployments that we've done using GameLift, we actually ran multiple fleets in multiple regions and tied them to multiple queues. And using a service like Route 53 with DNS, you're actually able to kind of point to different regional queues depending on the player's location. So it's very simple mechanisms that I'm describing here, but when chained together and building on top of that using the other AWS services, you can really have a global distributed fleet of game servers running kind of all over the world and available for players all over the world. And the great part about it is that it's all totally configurable and pluggable, and so it's very easy to just adjust if your game gains traction. If you're based in the U.S. and it gains traction and you start deploying to other regions in Europe or in South Korea, or Japan, you can actually leverage AWS's own infrastructure and spin up GameLift fleets in those regions that are close to your players, and then tie them back into your existing deployment using the queues mechanism. So it's very easy to just kind of continuously roll out new fleets to new regions for new player bases, and GameLift will kind of scale as you go. And I mentioned before, but the alias is kind of an abstraction. It's inherently tied to a fleet. There's a one-for-one mapping. So anytime you have an alias, it's associated with one fleet. And so the purpose of the alias is because the queue, it's all kind of an ordered thing, and if you're working with the service and you're working with the API, it'll all kind of make sense. But the queue is basically, you're configuring as an operator in the queue how to route to your game servers. And so if you were to just plug directly the fleets into the queues, anytime you get a new fleet, you've got to go update all your queues and then repoint everything, and it's a lot of work involved to do that. So the point of the alias is to address that and make a simple namespace. So maybe you have an alias just called latest, and so anytime you deploy a new fleet, you just swap the alias to your new fleet, and you don't need to go update the queues. Just by updating the alias, you've effectively routed traffic, and you're starting to move players over into new fleets and pools of compute. So that's the purpose of alias. It's equivalent to a DNS. It's a simple DNS mapping so that you can easily route traffic around and not have to update links every time you want to do a deployment. And so the fleets in GameLift are, under the hood, they're actually just EC2 instances and auto-scaling groups. But the fleets all scale based upon one key metric, which is % available game sessions. So as your application is communicating to GameLift using the SDK, and it's reporting the players who have joined and left, it's actually tracking the state of all the sessions of all your game servers. And so GameLift is scaling up and down servers based upon the available game sessions, because that is kind of the primary metric to go off of. Because the game session represents an immediately available game server ready for players. And so if you don't have any available game sessions, no new players can join or play your game. Only those who are currently playing can still play. But that triggers an auto-scaling event in which more instances are added to that fleet to accommodate gameplay. Alternatively, if depending on the breakup of the players of your game, if you're mostly based in the U.S. and you see players start to drop off during work hours because everybody's going to work and they're not playing the game, when the percent available game sessions drops under a certain metric, the alternative needs to happen. We need to actually scale down because we're not using these servers. They're just sitting around doing nothing. So it's full scaling capabilities out of the box with GameLift, and it's all based upon game sessions. All right, so I mentioned this previously, but here we're going to hash on it more. So part of using Spot, when you deploy a GameLift fleet using Spot instances or in Spot mode, there's a component to that system called FleetIQ, which is something that's running in the background. By using a Spot fleet, you're leveraging it. It's not an extra option you've got to enable. But the FleetIQ is just part of GameLift's backend, which is actually maintaining your fleets on your behalf when you're running things in Spot mode. And so the purpose of that, if you have a fleet that's running in Spot mode and the marketplace, you lose your Spot instances because the price has shifted, FleetIQ will actually shift you around on your behalf so that you don't get sudden termination of servers. So FleetIQ is actively kind of watching and tracking the Spot instance pricing activity and will make adjustments as needed to keep your game sessions open and available. Occasionally there are times where your Spot instances go away anyways, but there's a good 2-minute window mechanism that you can leverage to catch when that event occurs, and then the recommendation is to build into your game a way to seamlessly kind of roll off when Spot instances are due to terminate or some event happens. But in general, FleetIQ does a very good job at balancing the price and availability and kind of keeping enough servers running, and it'll always try to leverage the Spot instances. And in some cases, the GameLift team has seen a reduction of 90% of server costs. And they actually recommend using Spot instances pretty much just in general, but especially for games where it's maybe not as in demand and it's something that you want to kind of keep around for a little while. Spot instances are a great way to run and serve that game. And then, it's all tying back into the same mechanism of queues and the aliases and tying everything together. All right, from the monitoring aspect, so because the purpose of GameLift is to abstract away the overhead of managing infrastructure and managing a game and handling incidents and alerts and whatnot, they do still provide insights and monitoring of your game running on GameLift. And so there's a ton of metrics that are bundled in GameLift out of the box, and just running a game, you'll have access to all the metrics. And so there is a dashboard in the console of GameLift if you're working in the browser in the GameLift portion of the AWS console. But it's all just Cloudwatch, and you can also see all those same metrics in Cloudwatch and navigate and explore the metrics in there, as well as set up your own custom dashboards. And so for the majority of games and infrastructure that we've seen, it's pretty much never just GameLift. There's always some other thing involved. A lot of the times, DynamoDB is the go-to database, especially for these really high-noise, event-driven games in which they need just like streaming of data into a database and ways to kind of query that data set. So there's always other infrastructure involved, or at least most of the time. And all of the metrics of GameLift are exposed as just Cloudwatch metrics. You can build your own dashboard of all your infrastructure globally just in Cloudwatch, and then build in your own alarms and metrics, and even your own custom and math-driven alarms through Cloudwatch. Cloudwatch is a very powerful service on its own, and all of the GameLift internals are exposed to you through it. So you can really make use of it and have a really good handle on a good monitoring footprint of your infrastructure using these mechanisms. Oh, forgot to mention. So within GameLift, your game servers, you can actually configure additional functionality that leverage the AWS API. And so you don't, a lot of additional infrastructure automation can be built into part of your game server code that's running on these GameLift instances. So for example, we've seen games in which the game servers are all responsible for setting up a DNS mapping so that we could run and serve SSL certificates on the machines themselves, so we can encrypt user player traffic. So that you can basically leverage any of the AWS API actions on your GameLift servers to automate additional components as well. A really common thing is to have the game log file that's on the game server, and actually have a process to scoop up or tail that log file and ship it into the Cloudwatch logs service. So not only can Cloudwatch expose the metrics of GameLift, you can also stream your game logs into the GameLift logs, or I mean the Cloudwatch logs service, and query and check metrics and stats just from the logs. And Cloudwatch logs insights is another component of Cloudwatch that can be leveraged there, which can basically tail and parse the Cloudwatch log data, and you can even build alarms and filters off of that data as well. So you can add in components to your code. So in your log streams, basically include errors and warnings and conditions that can be logged, and then you as an operator could be notified when certain events occur, certain warnings or errors are coming through. Alrighty, so that was the run through on GameLift on the service itself. So kind of my final closing thoughts on it. It's a great way to get started and just start deploying infrastructure, and it's really easy to just roll out new fleets and new versions. A lot of the work around GameLift comes around configuring and tuning. So it is just like every other AWS service. It is API driven. Everything that you can do in the console, you can do in code as well, using AWS CLI or some SDK for your favorite programming language. And because of that, it makes it extra powerful because you can extend just the out-of-the-box capabilities with your own custom scripting and automation. And so what we typically do for customers is build a CI/CD pipeline around this whole system and basically have full suite automation. So from a development aspect, you can develop your game locally, test it, validate it, check it into source control, and have a development fleet deployed, and now you're testing and validating your game on GameLift. And it's just kind of like the traditional application deployment mechanisms. I mean, it's all kind of native to GameLift, and you can accomplish the same thing there as well. It's just slightly different abstractions. So instead of delivering files or bundles through something like SSH or code deploy, you're storing it on S3, and you're creating a build from it using the GameLift API. So there's just aspects which are slightly different from rolling your own infrastructure, but as a whole, it's a great service for running a multiplayer game and one that can scale globally using AWS's infrastructure. So that was the presentation. It's time for Q&A. I only saw one question come in, so if you were sitting on any and have any questions for me or for us, please send them in. All right, so we have a question. Are there any materials available that explain how to host Unreal 4 multiplayer games? Yes, so that is available in the GameLift documentation. I'll see if I can send a link through here. So it is also available in the Unreal Engine wiki. I don't know that I can send links through this webinar system, but if you just search wiki.unrealengine.com/integrating Unreal Engine with Amazon GameLift, there is a wiki page on Unreal's website which goes over how to integrate with GameLift, and they're specifically talking about versions 4.14 and 4.15. So yes. Alrighty, I think that was it for the questions. A little light. That's okay though. So to recap, we talked about GameLift and how it's an available AWS service that can be leveraged to run multiplayer games on the AWS platform. We talked about kind of our experience running and building game systems on GameLift and on AWS in general. And so if you would like any kind of further discussions or need some more insights, we offer a essay on-demand consulting session and can kind of help answer any additional questions or kind of guide you along in your path. Right. And so that consulting session is a free consulting session, and that's something that we can provide for anyone who's interested. And so I believe there's an attachment for that as well. PDF, free cloud consulting, AWS Certified Solutions Architect. So feel free to kind of reach out to us, and we can have a free consulting session and listen through any kind of game development or building questions that you may have, and we can answer those questions directly as well. Okay, everyone, thank you for your time. Have a great day.